So as I said, we're going to be looking at the equations of a circle as part of this last section. And to start off, let's just dive right into the basic format, what it means, and a couple of the example problems you're going to be seeing. The graph paper will come into play possibly if it helps to visualize. I'm not going to ask you guys to draw the graphs of any circles. But you do need to recognize what they look like when they're graphed and what the equation is for them. You'll get more of this in Algebra 2 next year and in pre-calc, but we want to start it here in geometry with all this other stuff we're doing. The basic formula is this: x minus h squared plus y minus k squared equals r squared. Now, in that equation, the y and the x are the usual y and the x from when we graph it. When you graph an equation or a system, you have to have the x and y's to generate points. That's what those x's and y's represent. The h and the k. So here's my... Where am I here? There we are. Sometimes green doesn't come through real well, so I can find where it ends up on the screen. There it is. H and K. Now notice it's minus H and minus K. The positive versions of those represent the center of the circle. Now if there's no number there, that means the center is at 0. So if I have a graph, let me switch colors again, when I can actually see. There we go. So if here's my graph, and the circle is centered right here at the origin, then the equation would just be x squared plus y squared equals maybe a radius of 3. Now, it would help if I actually hit a radius of 3. There we go. That's a little better. There we go. Boom, boom. And then r, that's my radius. So in this circle has a radius of 3, so right here I would write 9, 3 squared. It's always a radius squared. A lot of this has to do with the fact that, remember, a circle is all the points the same distance from a common point. So this looks a lot like the Pythagorean theorem. A squared plus b squared equals c squared. The x direction squared plus the y direction squared equals the hypotenuse, or the radius squared. So as another example, let's jot down a generic guy here for you. We might have x minus 3 squared plus y plus 2 squared equals 64. So for that circle, what's the center?
I'm confused with your lines at the top with graphing and h.
Oh, in the general form of the equation, that's this thing right here. Right? The x and the y are just there because I have to have an x and a y to draw a graph. And the equation has to have an x and a y so that I have an input and an output. The h and the k, the numbers that I'm subtracting, so h right here, k right there, those are the center. Those tell me where the center of the circle is located. And then whatever it equals is the radius squared.
So h and the k are always the same, right?
They change. Like this circle, what are my h and k?
The one out there?
Yeah, the one that's this guy right here.
0. Oh.
3 and
Negative 2.
-2. And what's up?
Alright, so I don't get the point of the equation if you use the graph.
If you have it graphed, you just look at the graph. If you don't have it graphed, you look at the equation. Or if you have it graphed and they say, what's the equation? Then you can say, well, where's the center? What's the radius? And then write your equation from it. So like in this guy, the center is +3, comma, -2. the signs switched when I pull them out. What about the radius?
They always switch?
Yep. Is what? 8. Because that is the square root of 64. Or you could say because 8 squared is equal to 64. Whichever one works better for you. So the idea is, in the formula, the x minus h squared plus y minus k squared equals r squared, everything I need to know about a circle is buried. It has the center of the circle, and it has the radius of the circle. And this guy, like for example over here that I did a quick sketch of, so this guy orbiting right over here, that one, because there's no adding or subtracting, the center is at 0, 0, and the radius is square root of 9, or 3. And that's why I can see right here it's 1, 2, 3 units to get to the edge. That's just probably the first time you guys have seen this formula. We'll look at a few more examples to kind of help shore it up. What's up? This would be this 64 right here. Or not sure where these came from. The bottom one. These are just me reminding you that the radius is 8 because the square root of 64 would be 8.
Were we given the radius of 8?
You'll be given the equation that has the 64 in it.
Oh, okay.
Or you'll be given the radius and be told, write the equation.
And so then you know. That's just,
You got it.
that's true.
Yeah.
Do you always have to switch the sign?
Always.
Center?
Always. Yep. For example, here, let me put this guy up here. Center of a circle is located at 0, 5. And the radius is the square root of 10. What would the equation be? Well, I'm going to start off by saying, well, let's see, what's the format? Let me write it down again so we have it. Is x minus h squared plus y minus k squared equals the radius squared. So let's see, h is there, x minus 0. K is 5, so y minus 5 squared. And then the radius is the square root of 10. So my equation for the circle, x squared plus y minus 5 squared equals 10. And let's try that again without clipping. Close enough. That's all I'm doing. I'm just basically plugging into the general form. The hardest part comes when the radius is something I have to calculate. It's not handed to me. Or when the center is something I have to find. That's where they get a little bit trickier.